Your user types something and your app lags, or worse still, it returns out-of-date results. Why? Because that async task that you thought was done is still running in the background. Let me show you. If you're new here, my name's Lee, I'm a senior software developer, and in this video, I'm going to show you the async mistake that's probably slowing down your app and how to fix it in just a few lines. So if we take a look at this simple demo app that I've created, we have a simple user type ahead. So in here, I can search for a user based on their name or email address, and I've pre-populated the database with about 200,000 rows. So if I type in more than 3 characters here, HIL, we can see that a search request was sent with the term HIL, and that has pre-populated the results. So I can then select a user. Great. But what if I start typing, a request is issued, but I continue to type? We can see here that quite rightly, as I change the search term, the previous requests are being cancelled and a new one is being issued with the new search term, which is great. However, let's go and have a look at what's happening on the server. So as you might expect, I've got a simple user controller which has a search endpoint that takes the search term from the text box. And that's being passed to a user service, and then the result is being returned in an OK response. If we're going to have a look at the user service, I'm using Entity Framework to go to the users table. I'm finding any users where the name or email address matches the search term, and I'm returning that. I'm also posting a log message to say that we finished the search for that particular search term. And if we take a look at the logs, we can see that there is an entry to say that each of those requests was still processed by the database and returned to the app, and then the response was returned, even though the client, our web page, is no longer waiting for that request and is not going to do anything with that response. So we're actually wasting resources here. And I've seen this about a year ago in production in a particular company that I worked with, where this was happening and they had a lot of user records. And as they continued to type, the request response just got slower and slower and slower because the app and the database was still processing all of those other requests that weren't needed anymore. And there's a really simple way of fixing this, but it's something that I see a lot of developers either ignoring or not really understanding what to do. So let's come over to our controller and let's add in, next to our string term, which comes from the text box, let's just add in a cancellation token. And if you don't know what a cancellation token is, it's basically a stop signal. So if we add in the cancellation token here in our controller, the ASP.NET Core pipeline will automatically populate that. And if the request is cancelled by the user, then the cancellation token will be triggered, and we can use that to stop processing any more of that request, and then we're not wasting any more resources, etc., on the server or the database. So all we need to do is add in a cancellation token to the controller. We don't need to worry about populating it. As I said, the ASP.NET Core pipeline will populate that for you, and they will trigger it for you if the user cancels the request. So you just need to add it to your controller, and it's as simple as that. We can then pass this down to our user service. And that's the important step. We need to pass the cancellation token down from our endpoint where it first comes into our app, all the way down to any async method or code that's going to be executed as part of that request. It's very important to do that. So let's go into our iUser service implementation, our iUser service interface. I'm going to add in the cancellation token. And then in our user service, I'm going to add that as well. Okay, and then in here, I'm now going to use this cancellation token to pass to our toList async. And you can see that Ryder's actually highlighting that for me. And if we go over to it, we can actually see it says method has overload with cancellation support, meaning that we can use it as toList async as we are now. But if you have a cancellation token coming in from your request, then populate it in here. So I can just pass in here cancellation token. And now that will get passed down to our database query and into Entity Framework. So if the request is cancelled, it's going to call the cancellation token in our controller, which will come through to our service, which will come through to Entity Framework, and it will actually cancel that database query on our database as well as our application. So now let's run that again. So back over in our demo app, if we type in some letters again and then continue to type, we can see the type ahead has cancelled all of those other requests. And if we come back over to the log in our application, we can see that there's only one message saying that the search was completed. And that's because now our request and the database has cancelled its processing of the existing requests and just concentrated on the new one. So that really helps not to slow down and waste resources of your application and your database. And in big applications or big databases, this can really make a huge difference. Now, granted, the type ahead should at least wait a few seconds for the user to stop typing before we send the request to the server. Rather than just sending it immediately as soon as they type every single letter. However, this particular type ahead comes like this as default. So you actually have to know to go in and actually set that setting. But even still, even with that setting, this can still happen. So it depends on how long your search results take to come back. So it's really important to add cancellation tokens, not just for type aheads, but for all of your requests. And granted, if you have a large code base already, it might take some time to go through and add this, but it really can make a difference, particularly where you have large database queries or lots of different things happening, maybe not just one database query, maybe you have lots of things going on, API calls and so on. So you can actually pass the cancellation token to a HTTP client if you're making a call to a downstream API, for example. And so we can ensure that that gets cancelled and then that app cancels what it's processing. So it's really important, not just for your app, but for downstream services as well, to properly implement cancellation tokens. And it's so simple. And if you're using something like minimal APIs, it's just as easy to add that as well. So I have the same endpoint set up here with the term, and I'm also injecting the iUser service to be able to do the same query we were doing before. But once again, you can just simply say cancellation token and have that as a parameter in your request, and then simply pass that down to your service, and that will work in exactly the same way. And likewise, if you're using something like fast endpoints, which I covered in my previous video, you'll already have a cancellation token being passed in as part of your handle method, which you can then pass down to your service. So there we have it, a really quick and easy way of improving the performance of your application and your downstream services. Subscribe for more .NET tips, and I'll see you in the next one.